let's look at an example of comparing decimals using a number line. My problem says, or my question asks, which is the bigger number, 0.63 or 0.25? I am going to graph these two numbers onto my number line. And since there's zeros in the ones place in both of these numbers, I know that my numbers are going to fall somewhere between 0 and 1. So I only need to look at that small section of the number line. So I've taken my 0 and 1 and divided it into tenths. So it's kind of hard to see with these little numbers, but we've got our markings at 1/10, 2/10, 3/10, 4/10, 5/10, 6, 7, 8, 9/10, and back up to our whole number 1 here. So now, without getting any more detail than that, we can show approximately on our number line where these two numbers are going to fall. So for my 0.63, I know that it's going to lie somewhere between 0.6 and 0.7. So it's going to be somewhere over here. For my 0.25, it's going to fall right between my 0.2 and my 0.3. So it's going to fall right here. And since we know that anything to the left on our number line is less than anything to the right on our number line, we can see that 0.25 is less than 0.63. So our question though asked us which is the bigger number. So let's write our bigger number first in our solution, and we'll say 0.63 is greater than, the bigger number is bigger than 0.25. You can order a set of decimals or a set of numbers either in order from least to greatest, increasing, also sometimes called ascending order, or you can order them from greatest to least, or decreasing, also called descending order. We're going to look at an example in which we're asked to order a set of decimals in ascending or increasing order from least to greatest. So let's look at this example here of a set of decimals that we're asked to order. Arrange the following decimals from least to greatest. So on our number line, remember that least, the lower numbers are to the left, to greatest, the larger numbers are to the right. So what we're going to do is we're going to find on our number line each place that these numbers would be, and they can be approximations, and you'll see that we'll be able to see the order from left to right. So we look at the whole numbers here as being 0 and 1, and so we can see that all of our numbers are going to fall between 0 and 2, because the numbers we have that have a 1 in the whole number place, and then the decimal after, we know are going to be to the right of 1. So we're going to go all the way up to 2, so we're sure to be able to fit in our 1 point bigger decimal numbers. So we'll start here with our 0.288, and we know that 0.288 is going to fall somewhere between 0.2 and 0.3 on our number line. So I've taken also from my 0 to 2, and I've marked out tenths places. So I'm not writing the numbers below them, but you can see my little hash marks that this is 0.1, 0.2, 0.3, 0.4, 0.5, 6, 7, 8, 9, my whole number 1, and then remember to the right here is going to be 1.1, 1.2, 1.3, 0.4, 0.5, 0.6, 0.7, 0.8, all the way up to 1.9, and up to my whole number 2. So in case any of my decimals here with the 1 in the whole number place has a 0.9, I'm going to be putting that one way up here to the end. So let's take a look here. My 0.288 is going to fall somewhere between 0.2 and 0.3. And so I can just do a little mark here, and I'll put my 0.288 here, that it's going to be between my 0.2 and 0.3. 1.2 actually already has a little hash mark because it's 1 and 2 tenths. So 1 and 1/10, 1 and 2/10, it's actually right here, my 1.2 on the number line. And then this one here of 0.028 is going to fall between 0 and 0.1. It's less than 0.1. So it's going to be way down here between my 0 and my 0.1. So 0.028 is probably, I'm thinking, going to be my smallest number. And then I've got 0.12, which is going to fall between 0.1 and 0.2. So here's my 0.1 and here's my 0.2. So my 0.12 is falling in between these two. And then the last one looks like it's going to be my biggest number. 1.288 falls between 1.2 and 1.3. So here's my 1.2 and here's my 1.3. So here, between these two marks, is going to be my 1.288. And now that I've got all 5 of my numbers graphed onto my number line, I can simply read from left to right is going to be my smallest number to the left, my largest number to the right, and I can put these in order with my greater than signs and less than signs in between. So let's start right here. This can start us right here with our answer because our smallest number in our set is 0.028. And then as I move to the right, the next one I marked off was this one right here. So my next number is going to be 0.12. And then I'm still moving to the right. My next number here is 0.288. So far I've got 0.028 is less than, because it's to the left of, 0.12, which is to the left of, or less than, 0.288. And then I'm moving up here, and the next one I graphed was my 1.2. So 1.2 comes next in the ascending order of my numbers. And then my last one, the greatest number of my set, is this last one here, which is 1.288. And if I had had a 1.9 or a 1.95 or some number way up here close to the 2, that would have been even greater than 1.288. But I stopped right here at my greatest number in my set of 1.288. We could also graph this problem onto a number line and we'll see that our solution is the same. So my 5 is right here. 5.02 would be next, right here. And then 5.8 would be clear up here, 5.8 on the number line. And my whole number 6 would be right here. And I would see that if I'm looking at my decimals from greatest to least, I've got 6.0 is greater than 5.8, is greater than 5.02, is greater than 5. And I'd see that I have the same solution by graphing it on a number line.